Yep. All right, here we go. We're going to talk about contradiction, identity, or conditional equations, okay? A conditional equation means that you have one solution, x equals a number. Does that make sense? Okay. A contradiction means that you have none. There's no conclusion. It's a false statement. Like it's going to become, it'll say 0 equals 1, which is that true? No. Yes. It is? Okay. Identity means you have infinite solution. And what it happens is it comes down to being 0 equals 0. And then we say it's an infinite solution. Got it? All right. So let's see what type we have. So we're going to go through and solve this bad boy. The first thing I need to do to solve is what? What am I going to do with the parentheses? I'm going to distribute the negative. So we get 5 minus 4 plus x equals 1 plus x. What's 5 minus 4?
1.
And what do you notice?
They're equal.
They're equal, okay? If I keep going, so if I subtracted 1 and subtracted x, what is it going to come down to being? 0, right? It's going to be 0 equals 0. And what did we just say 0 equals 0 meant?
What?
Contradiction, identity, or conditional? Identity.
What does that mean again? Contradiction is the one where it's not true.
So contradiction is it's false. It makes a false statement.
Yeah.
Conditional means it's x equals a number. Identity means when you come down to it, it becomes 0 equals 0. So do we see why it's an identity now? All in agreement? Identity. Yeah? Questions, comments, or concerns? Positive? Okay. C needs to know what is contradiction. So what is a contradiction? Contradiction means it's a false statement, right? That means I have nothing. Well, 0 equals 1. It makes a false statement, right? What does identity mean? I come down to
0 equals 0.
0 equals 0. And what does conditional come down to? X equals a number. Okay. All right. So I'm going to pause and let you guys do this one. I know. Clearly, none of y'all did. All right. So the first thing you should have did was distribute, right?
Yeah.
So we got 3x minus 1 equals 4 minus 16x. Okay? Then what do I need to do? Combine like terms. So I'm going to add the 16x and add the 1. Does that make sense? We're all in agreement? So we have 19x equals 5. Last step. Divide. So what do we end up with? And so what kind of problem is this?
A
Conditional, because I actually got an answer. Does that make sense? How do we feel about conditional?
Good.
Good?
Yes.
You don't like it?
We always do.
Huh? Yes, conditionals are the typical problems we get, right? All right, we'll quickly go through this one together. So first thing I need to do. Oh, let me let you. You know what? I'm gonna let y'all start it.
You want the final answer or you want to go through it?
Yeah, what do we do?
Distribute. Okay, I'm gonna distribute the -3.
Good job distributing the -3. Okay, done. What's next? Combine like terms on the same side. So this became okay. Then what did you do?
Combine like terms again.
Combine like terms. So I'm going to add 3x, subtract 3. Is that cool? So this ends up being -6 equals 0. So this is a what? It's a contradiction. Because it makes a false statement, so there's no solution.
Is 0 equals -6? That's, I mean, that's obvious. That's still a right answer?
Yeah, so there's no solution, and it's a contradiction. Yes, no? All right, how do we feel about contradictions, identity, and conditional equations and identifying them?
Contradiction, like, only the like,
It could be any number. It just has to be a false statement, but it'll always usually come down to 0. So it'll come down to 0 equals something that's not 0. Yep. Then it's a contradiction. Yep. All right. Now we're going to talk about how to solve in the calculator. So please make sure you have a TI-84 on your table. There are Inspires mixed in because of my WIN class, so don't grab those. I do. I actually teach during that time.
Yeah, I know.
Well, my class is an intervention class, so I have to teach. Where are you going? Okay. Good luck. All right. So what should we do when we get a new calculator? Clear. And how do we clear it? Carefully. Perfect. Second plus 712. Second plus 712. Okay.
Partially clear.
Just in case someone changed the settings or put their own information in, it won't interfere with your data. Second plus 712. Okay. So these are the steps that we're going to follow. So step 1 says we're going to type the left side of the equation in y1 equals. So I'm going to go to y equals. And in y1, I'm typing in the left side of the equation. And my left side is 2x plus 1. Your X is right next to the alpha button. It's your variable key is right next to alpha underneath mode. Okay, then you're going to type right side of the equation in y2. And the right side of my equation is x plus 2. It says type left side of the equation in y1 equals. Type right side of the equation in y2 equals. That's all I've done so far. Step 1 and step 2. Please check with your neighbor. Y equals.
So,
Yes, if you've done this part, then you're going to graph. Okay. When you hit graph, you want to make sure you can see where the two lines intersect. Do you see the two lines intersect? Okay. To find the value of their intersection, you're going to press second trace 5. Press trace is at the top next to zoom. So you're going to press second trace 5 for intersect. And you're going to press enter 3 times. Yes, literally 3 times. And what does it tell you? So your intersection is at 1, 3. So that means your solution is x equals 1. And that's how you do it graphically.
should we write all of that down?
It's up to you. I go over it. I don't, because we know how to do it without the calculator. So, all right. So because x equaled a number, therefore this is a conditional. On the 84 and 83s, yes. So this is a conditional equation because x equaled a number. Does that make sense?
Yes.
What are your questions about calculator input?
No.
I just have to introduce it to you and show it to you. I've shown it to you, but is this the only means of solving this? So if you freak out on a test and you don't remember the steps, what does that mean you do? You solve algebraically, right? Okay. Now, symbolically just means to look at the table. So symbolically means looking at the table. If we go second graph and look at our table, you're just looking for when are your y values the same and when are our y values the same. They're the same at x equals 1. Do you see that?
1, 3, 3.
Mm-hmm. So you're looking for when is y1 and y2 the same. Second graph. All right. Any questions about graphically and symbolically? No? Easy enough? Cool. All right. So we're going to move on. So here it says we have a word problem. It says 1973 to 2007, oil consumption in millions of metric tons by the Middle East could be modeled by M of x equals 10 and 1/10 x minus 19,904, where x is the year. Similarly, oil consumption by Eastern Europe could be modeled by E of x equals 2 and 8900 x minus 5,622. Determine the year when consumption in these two countries are approximately equal. So we're going to do what we just did in the calculator again. So we have two equations and we want to know when are they equal, approximately equal to each other. Does that make sense? So this would be my first equation and this would be my second equation. So I'm going to go to y equals. I'm putting in 10 and 1/10 x minus 19,904. Then I'm going to clear y2 and I'm putting in 2 and 89/100 minus 5,622. Okay, now we are going to graph it. Now notice that when I press graph this time, I can't see anything, right? So what we're going to learn how to do is use what's called zoom fit. So you're going to press zoom, and you're going to scroll until you see zoom fit. So we're looking for zoom at the top in the middle. Y'all must not be really good at word searches.
No.
Because something concerns me when y'all are looking on these. All right, for me, if I go up, I go straight to zoom fit. I don't know about on your calculator, but on mine, boom, you see zoom fit? I just go up on mine.
No. How do we get that?
Zoom.
That makes sense. Hey, bro, why are you there?
Okay, so I'm going to arrow up and I'm going to hit enter. And notice the calculator is going to do some thinking and it's going to be like, oh, I tried to zoom my best ability for you. And you're like, oh, well, graph, you show me nothing. I don't see where these two intersect. So now you're just going to have to zoom until you see it. Okay, so I'm going to zoom out a little bit because sometimes zoom fit does the work for you. And if you can get it to do the work for you, why not?
Right.
I still do not see it. Move my cursor over a little bit. All I'm doing is playing with the zoom until I see something. All I'm doing is playing with the zoom until I see something. I did zoom fit and zoomed out. Yeah. Good job. I'm almost there. I'm going to keep moving my cursor over a little bit. So zoom out. And it's going to ask you, where do you want me to zoom out to? I need you to zoom out over here. I'm getting closer. I'm like, ooh, I think they're overlapping somewhere. It looks like they're touching each other now. So now I'm going to try second trace. 5. All you're doing is zooming. I can't tell you how many times to zoom. I can't tell you where to zoom. You just got to zoom until you see it. You can try other zoom settings. You can try zoom decimal. What does zoom decimal do? Didn't work. You can go back to zoom standard and start from there. Okay. The other option that you have is to change your window. So I can change my window. I'm like, well, I shouldn't need any negatives. My X values are going to be really high because it's like 1973 to 2007. So let me go, I don't know, 2010. Where they intersect. Second trace. I'm going to count by 1,000. Again, I'm going to say 0. And my y-intercept here is -19. Goes pretty deep down there. Let's say 20,000. Because I got tired of playing with the zoom feature. What's what? That's just what you wanted to count by. Your X scale? What do you want it to count by? I'll let this count by 1,000. All right. So I made some new settings. Calculator is going to think, and it says, oh, ma'am, you are way off on your settings. I'm like, oh, ding dong. I'm just showing you that there's other ways. And I'm showing you how when that didn't work. Did I quit? Did I complain? No. I just said, okay, let me try something else. Okay, I'm showing you how to persevere when you don't get it instantly. Okay? So back to zoom fit. I'm going to zoom out on zoom fit a little bit. Here. Okay. I need to get out of the. Why? Because I'm zoomed in so much. So it's going to look that it's horizontal, but is it really horizontal? I'm just not there yet. I need to get out of the negatives, though.
Yeah, exactly.
You found it? Good.
Yeah.
No. You can tell me your window settings. You press window and then tell me what numbers you have in there.
Okay, so, for the X bin, I got 27,033.6.
I'm just gonna put 28.
For the max.
You said 27,000? Like 28?
Negative 27,000. I didn't see that. The black row was on there first.
Okay. What's your max?
Max is 27,033.
27,033 or 2,733?
I'm pretty sure this is 5 digits right here.
Okay, just checking. My scale?
1.
Okay.
The Y min is negative 60,793. The max is 60,793.6. Is what I got on there.
I was getting there.
On both. For the scale, 1.
Oh, there it is.
Oh, there you go. See, it looks like mono.
And now I hit second trace. And I go 5. And how many times do I press enter?
3.
And boom. So what year were they approximately the same use of oil? 1980. So is it okay? I'm gonna write between 1980 to 81. This is like almost at the end of 1980.
And how do you go?
Yeah.
Second trace. What is that for? Oh, to help you? Oh, okay. I'll give you a minute. Thank you.
Okay, want to go?
I'll give you
5:30.
Do you need help with that?
You'll be on the field. What do you mean? All right. So that's how that works.
You put some snacks in.
All right. So what we have here are just other things that you can solve for. So also in algebra, a key thing is sometimes you're just moving variables around. Does that make sense? Based on what so you may not get a numerical value because you're just moving the variables around. So in this situation, it wants us to just move the variables around to get L by itself. So the first thing you want to do is move everything that doesn't have an L in it to the other side. So we're going to move all terms without L. So what terms do not have L? These two.
Okay.
2WH. So how do I move it to the other side? Subtract. So I'm subtracting 2WH. So that's going to leave me with S minus 2WH equals 2LH plus 2W. No, I'm sorry, 2LW. And I don't know why I wrote it backwards.
When you said factors, you combine them.
They're not like terms. Remember, you only can combine things that are exactly the same. Math. Whoa. Okay.
See, math was my favorite subject, so I can't work on this.
Lovely. Step two. Step 2 is you're going to factor out your variable. So we're going to factor out the variable. Factor out means we want to take out L from all the terms that are left. So we're going to divide U by L and divide U by L. And what will we be left with? There we go. And when you factor out means it goes to the outside of the parentheses. So we're left with 2H plus 2W. And the final step is to move everything but the variable. So if I'm multiplying L times 2H plus 2W, how do I move it? I got to divide it. So I'm going to divide. And then when I move it, I'm going to be left over here. So when it's all said and done, we have S minus 2WH divided by 2H plus 2W equals L. And that's how you isolate a variable. I'm not.
What questions?
All right. Oh, the last step was to divide. Okay, so we move all terms without the L. Could it be any other letter, right? So whatever the variable you're trying to get. So you move all the terms without that letter. Then you factor out the letter. And then you divide to get it completely by itself. Okay. This is useful when you have multiple things to solve for and plug into a problem. This is why it's useful to go ahead and isolate that variable so that you're not constantly dividing and multiplying and adding using inverse operations.
Oh, so you would divide on both sides?
Mm-hmm.
Is that it?
And that's it. Yeah, we have a couple more word problems to work, but for the most part, that is it for 2.2. Just more word problems and oh, sorry. Questions about isolating variables. All you're doing is using inverse operations mixed with a little bit of baby factoring. Okay. The other thing I just want to remind y'all is that some of the equations that you've known before come back into play. So like setting up proportions, Pythagorean theorem, things that you should already have from geometry. So in geometry, you should have set up proportions a lot and you should have used Pythagorean theorem, right? Yes. Okay. So setting up a proportion, for example, here, it says a person is 5.5 feet tall and they make their shadow is 7 feet from with the street light, and it wants to know approximately how tall is the street light. Remember in geometry you learned that all right triangles are 90-degree angle, right? But they are also congruent to each or proportional to each other. So if I create a right triangle here, that this one is 5 feet of the person over 7 feet, then if I want to find the lamppost, it would be X over, and how far away from the lamppost is it? Not 20, but 27. And how do you solve that? Butterfly, you cross multiply and divide. So those are those tying into your geometry skills that you're expected to have and kind of pull out of your magic file cabinet to solve, okay? I know you're like, what? You want me to do what? Okay, your magic file cabinet in your brain. But you can, hopefully when you see something set up like this, if you think, oh, butterfly, oh, cross multiply and divide. Does that trigger or no? Yes, maybe so. Okay, please don't do that. And then we're going to divide by 7. I'm still on the graph, and y'all weren't going to tell me. 5.5 times 27 divided by 7. So approximately how tall is the lamppost? 21.2 feet. So now we know an approximate value of the lamppost. This is literally from, please stop, please stop, please stop. You're messing with my pen.
Oh.
Okay, it's literally, so this is proportions, and setting up proportions is an 8th grade teak. So we're pulling in some 8th grade teaks here, but reminding you of how it looks and when it's set up. Okay. How do you feel about proportions and remembering a little bit of geometry? All right. Well, that's all I have for you for 2.2. Tomorrow.